Offshore wind platforms could host AI data centers at sea. AI infrastructure developers are increasingly confronting a difficult reality. The rapid expansion of artificial intelligence computing is running up against limits in land, electricity supply, water availability, and cooling capacity. Aikido Technologies is proposing a different approach, placing the next generation of high density data centers offshore, directly alongside renewable energy generation. The company has introduced the AO60DC, a floating platform designed to integrate a large offshore wind turbine, battery storage, and AI grade computing infrastructure on a single structure. Rather than building massive data campuses near cities where land and grid capacity are constrained, the concept centers on locating compute resources closer to the energy source. Each platform is designed to support roughly 10 to 12 megawatts of computing capacity, paired with a 15 to 18 megawatt wind turbine and onboard battery storage. Multiple platforms could operate together as offshore AI infrastructure farms, with combined IT loads ranging from about 30 megawatts to more than 1 gigawatt. According to the company, facilities positioned within roughly 200 miles of major population centers could still maintain low network latency while allowing countries to retain control over both energy production and digital infrastructure. Rethinking where AI infrastructure is built. The growth of large-scale AI computing clusters is putting pressure on traditional data center markets. Hyperscale facilities require extensive power connections, land for large campuses, and substantial cooling capacity. In many regions, securing all three has become increasingly difficult as electricity demand rises and suitable development sites become scarce. Aikido's offshore model relocates key elements of that infrastructure to areas with abundant wind resources. Seawater can also serve as a continuous cooling source, potentially reducing reliance on freshwater systems often used by land-based facilities. The platform's wind turbine and battery system are intended to supply the majority of the data center's power for much of the year. A grid connection would remain available primarily to supplement operations during periods of lower renewable generation. Developers say placing facilities within national waters but near coastal network infrastructure could maintain round-trip latency below 10 milliseconds, low enough to support many AI and cloud workloads. The concept echoes earlier shifts in offshore oil and gas development, where deep water platforms expanded access to new energy resources. Modular platforms designed for offshore deployment. The AO60DC is based on a semi-submersible floating platform, a structure widely used in offshore oil, gas, and floating wind projects. Aikido says this design allows the system to be installed using existing offshore vessels and supply chains. The company describes the platform as a modular system that can be assembled more quickly than traditional offshore installations. Prefabricated data halls would be built onshore before being lifted onto the platform during final assembly, an approach intended to simplify integration and reduce construction timelines. The integrated structure combines a semi-submersible steel platform supporting both turbine and data infrastructure, onboard battery storage to stabilize power delivery, prefabricated data halls installed during offshore assembly, a direct connection between the turbine substructure and computing facility. This model could allow developers to scale projects by deploying multiple platforms within the same offshore wind zones. Aikido estimates that more than 50 gigawatts of offshore wind development areas already designated globally could potentially support similar hybrid infrastructure. Cooling is another central design consideration. The platform transfers heat from server systems through the steel hull into surrounding seawater using a passive thermal exchange process. The company projects a power usage effectiveness, PUE, below 1.08, a level comparable with some of the most efficient data center designs currently proposed. Aikido expects the temperature impact on surrounding waters to remain confined to a small zone close to the platform. Because the facilities would be located far offshore, visual impacts on coastal communities would also be limited. Maintenance operations would rely on vessels already used in offshore wind and deepwater energy projects. Technicians could stay on board during extended service windows, while maintaining uptime standards similar to land-based data centers. A proof of concept platform is currently under development in Norway, with deployment anticipated later this year. The company is targeting a first commercial project in the United Kingdom around 2028 as it evaluates whether co-locating renewable generation and AI compute offshore can address growing infrastructure constraints on land.